Alright guys, in this video I'm going to show you how to answer questions from Moment or under Moment. So let me not forget, if you are new to this channel, subscribe and share this video to your friends. And I'm 100% sure that this question may come in your paper. So the question is saying a block of weight 9.0 newtons is placed at one end of a beam, resting on a pivot as shown in figure 4.1. So we have the beam and also the block being placed at the ending point here. Now, apart from this one, we also have point X here, and also the distance from the pivot up to where the block is placed, and also the distance from the pivot up to where X is. Now, the first question is saying, which is question A, calculate the moment of the block about the pivot. So the first thing here, we need to know the formula. In physics, formulas are very, very important, and also the units. So we can say the moment of the force or the turning effect of the force is going to be equal to force multiplied by what? Distance. Where force is going to be in newtons, or we can say it can be also represent the weight of an object. So we are going to say the force of the block or the weight of the block is what? 9.0. So 9.0 newtons multiplied by the distance from the pivot to where the block has been placed is this one here, which is 0.8 meters. Then when I multiply here, the moment of a force is going to be 7.2 newton meter. So this one is our answer for the first question. Now, on this part of the answer, they have included for us the units, so we just need to write 7.2. That's all. The next question. B, it is saying, the volume of the block is 0.00018 meter cubic. Calculate the density of the block, giving your answer or give your answer in kgs per meter cubic. Take gravitational field strength as 10 newtons per kg. So the gravitational field strength is 10 newtons per kg on Earth. So collecting the data here, we can say the volume that we have here, it is 0.00018 meter cubic. Then apart from that one, we also have the gravity on Earth, which is 10 newtons per watt per kg. Then we also have the weight of an object, or the weight of the block, or the force. So this weight here, we are just going to get it here, or the force. So we can say we have 9 newtons. Then they are asking us to calculate the density. So we can say the density here we don't have. Now, by writing the formula for density, we can say density is equal to mass over what? Volume. Now, from this data that I've collected here, do we have the mass? We don't have. So we can say the mass also we don't have. There is a need for us to find the mass. How are we going to find the mass? We are going to find the mass by using the formula for calculating the weight of an object, where we are going to say weight is equal to mass multiplied by what? Gravity. This is the formula that we are going to use. So we can say the weight that we have here is just going to be 9 newtons. So we can say 9 newtons being equal to the mass, which we don't have, multiplied by the action due to gravity, which is 10 newtons per kg. Then when I divide here, the mass is going to be equal to what? 0.9 kg. So this one is our mass that we are going to use. So we can say the mass here is going to be 0.9 kg. So let's replace now here. What is our mass? Our mass is 0.9 kg divided by the volume that we have here, which is 0.0018 meters cubic. Then when I divide, I'm going to get 5,000. So we can say 5,000. Now in terms of the units, we can say 5,000 kgs per meter cubic. So that one is our answer. Now the last one, which is C. It is saying a weight of 18.0 newtons placed at point X in figure 4.1 will not balance the beam. Explain why. 1 mark. So let's see. If at point X here, we place 18 newtons, is this side, which is the clockwise moment, going to balance with the anticlockwise. So let's see. The moment for anticlockwise here, it is 7.2 Newton meter. So let's try to find out the moment of a force on the clockwise. Similarly here, I'm going to use the same formula where I'm going to say moment of a force is going to be equal to force multiplied by distance. So in this case here, the force is what? 18 newtons multiplied by the distance, which is 0.4 meters. Then the answer that I'm going to get here, when I multiply 18 multiplied by 0.4, then the answer is going to be 7.2 Newton meter. As you can see here, it is balancing. The clockwise moment is equal to what? The anticlockwise moment. Now let's see the question. The question is saying, a weight of 18 newtons placed at point X in figure 4.1 will not balance the beam. Then we need to explain why. Of course, it is balancing when we do the computation. Now we need to explain why when 18 newtons is placed at point X is not going to balance the beam. So we are going to say this is because the clockwise moment is not equal to the what? The anticlockwise moment. So that one is the answer. When the clockwise moment is not equal to the anticlockwise moment, the beam is not going to be balanced. But if the clockwise moment is equal to the what? The anticlockwise moment, you are going to find that the beam is going to be balanced. So that was the last one. Thanks for watching, and remember to share this video to your friends.